All right, let's take a look at this question. On a cross-country flight, point A is crossed at 1500 hours, and the plan is to reach point B at 1530 hours. Use the following information to determine the airspeed required to reach point B on schedule. And then we're given the distance between point A and point B is 70 nautical miles. Forecast winds are 310 at 15 knots. Pressure altitude is 8,000 feet. Ambient temperature is negative 10 degrees Celsius. And our true course is 170 degrees. All right, so I'm assuming that this question is asking, it doesn't specify, but I'm assuming it's asking based on the information in the table for a calibrated airspeed, which in level cruise flight is roughly indicated airspeed. So they're asking, when you're level cruise looking at your airspeed indicator, approximately what value are you going to need to fly in order to reach, actually to travel from point A to point B in the allotted time, which in this case is 30 minutes. 1500, yeah, 1530 minus 1500 gives you 30 minutes of travel time, 70 nautical miles to cover. So we need to figure out, number one, what is our required ground speed to cover 70 nautical miles in 30 minutes? And that's pretty easy math at this point, right? If you're trying to cover 70 nautical miles in a half an hour, you basically need to take that 70 nautical miles you would travel in an hour and double it. You want to get there in half the time, so it's 140 nautical miles. But just for the sake of demonstration, let's say it wasn't a simple 70 nautical miles in 30 minutes. Maybe they ask, the time between the two would be 38 minutes. So the way that you do this on the E6B is pretty easy. You have your middle scale here, which is your short time, and you have the outer scale, which is your speed and distance, and it just depends on the context of the question that's being asked. So in this case, we have 70 here. That's our 70 nautical miles we want to travel, and we want to cover that 70 nautical miles in 30 minutes. So we'll line up 30 minutes on the inner scale with 70 here. Go find our speed, our rate index right here, and that is in fact it's 14 on here, but in the context of the question being asked, it's 140. Again, I mean, if the question was, 38 minutes versus 30, line up 70 with 38 on the inner scale, find our rate index. And in this case, in order to cover 70 nautical miles in 38 minutes, we would be required to have a ground speed of, 108? Yeah, 108. So that's how you find these rate and distance questions using the E6B. And for this one, you don't need the E6B. It's simple math, 140. So our required ground speed is 140 knots. All right, the next thing we need to do is take our required ground speed and figure out what true airspeed that we're going to need to maintain. So required true airspeed. So for that, let's flip over onto the wind side. This is sort of, it's exactly the type of calculations you do when you do cross-country planning. But usually we start with a true airspeed value found in your POH and then figure out ground speed based on winds. In this case, we're going to work in reverse, but the concept is the exact same. So they've given us a forecast wind of 310. So we'll go ahead and put our wind in on the calculator. So set our winds to 310 and 15 knots. So again, I just want to slide the center of this ring here down to some index value. I'm using 120 here, and we're just simply going to count up 15 knots. So 120 to 130, that's 10 knots, and then right in between, there is 15 knots. So we've got our wind set. Now we want to rotate our true course 270 and set up our wind calculator with our true course here. Now, we are looking for the required true airspeed to maintain 140 knots ground speed. That center reference point is always your ground speed. So I'm going to take this, slide my ground speed up so that center is on 140. And then I'm going to go find my wind mark, zoom in on there, 150, we'll call it 152. Probably not exactly centered up. There you go. 152 knots true airspeed. Based on the winds, we're going to have a true airspeed of 152 knots in order to cover 70 nautical miles in 30 minutes. The required true airspeed is 150. All right. That's great, but we don't have, well, sometimes we have true airspeed displayed in the cockpit. However, we just have a standard airspeed indicator to go by. We need to flip back over to this side of the E6B and figure out what our required calibrated airspeed is based on the altitude that we're traveling, the true airspeed that we're making, and temperature. So the way that you do this is enter windows here. And to do airspeed corrections, directions are right here. Set your pressure altitude opposite the temperature in degrees Celsius in this window. And then you're going to use the two scales up here to read your airspeed corrections. All right. True airspeed on the out, calibrated airspeed on the inner scale. All right. So what are we given? We're given a pressure altitude of 8,000 feet, an ambient temperature of -10 degrees Celsius. So in this little window here, we have our pressure altitude. In this window, we have our air temperature here. We are looking for, so we're negative to the side. There's 0 degrees, 10, 20, 30, 40, 50. So we're 10 degrees, and we want to set 10 degrees over 8,000 pressure altitude. So 5,000, 10,000, there's the 8,000 mark right there. So we have 8,000, -10 degrees Celsius, and then we go look for required true airspeed was 152. So we go on this outer scale. There's 140, there's 150, 160. So each one of these marks is 2 knots, 152. And then we drop down from the outer scale, the inner scale, about 135, 6, 7. 137 is our required calibrated airspeed to travel 70 nautical miles in 30 minutes. And that makes our answer for this question C.